Bismillahirrahmanirrahim. Students, this is your tutor Hassan Bilal, and we are covering chapter 4, turning effect of the forces of class 9 physics, and we are going to cover the second condition of equilibrium. We have already discussed the equilibrium, first condition of equilibrium, and now we are going to cover the second condition of equilibrium, and we are going to cover the states of equilibrium. What are the three states of equilibrium? Students, this is your book of class 9, and we are progressing from page number 98 onward. Yes, we are progressing from page 98 onward, from second condition of equilibrium. Students, we have discussed the first condition of equilibrium, and we have discussed that in first condition of equilibrium, the summation of all the forces acting along x-axis and y-axis, that must be zero. This is the first condition of equilibrium. And if we consider this diagram, you have seen that the line of action of the force is the same. So when the line of action of the force is same, then you can easily apply the first condition. Here, the summation of all the forces along x-axis and y-axis, that must be zero. So you can easily, you have seen that there are two forces, F1 and F2. They can easily cancel each other effect. These forces are along x-axis. Whereas when the line of action of the forces are changed, you have seen the line of action of the forces are changed. So when the line of action of the forces are changed, the body has a tendency to rotate to produce a torque. So if the body has a tendency to rotate or produce a torque, then in addition to the first condition of equilibrium, there requires a second condition of equilibrium. So we are going to explore that what is that second condition of equilibrium. The second condition of equilibrium states that a body satisfied second condition for equilibrium when the resultant torque acting on it is zero. So when the resultant of torques, when the summation of torques, when you add the torques, summation means add. So it's a sigma, which is represented by E, like that. So sigma means to add the numbers. So when you add the torques, for example, anti-clockwise and clockwise torques, and the answer would be zero, so the second condition of equilibrium satisfied. Whereas in first condition of equilibrium, you have seen that sigma F, the summation of all the forces, must be zero. But in second condition of equilibrium, sigma torque must be zero. So summation of all the forces acting along x-axis and y-axis, that must be zero. This is the first condition of equilibrium. And summation of all the torques acting, summation of all the torques clockwise and anti-clockwise, that must be zero. So this is the second condition of equilibrium. So we have discussed that if the body has a tendency to rotate, then in addition to the first condition of equilibrium, there requires a second condition of equilibrium. And we have discussed that second condition of equilibrium states that summation of all the torques acting on the body, that must be, summation of all the torques acting on the body, that must be zero. We take an example that two children are playing on a seesaw. These are two children are playing on a seesaw. So you have seen that girl will, the weight of the girl is actually downward. So that girl will produce a torque, and that will be anti-clockwise torque. And that boy will produce a torque because his weight is acting downward. So that boy will again produce a torque, and this will be a clockwise torque. So both the torques, when you add these torques, when you add these torques, clockwise and anti-clockwise torque, the answer would be 0. So it means that here in seesaw, the second condition of equilibrium satisfies. So this is the second condition of equilibrium. So now the question arises that a ladder leaning at a wall, is it satisfying the second condition of equilibrium? It's so simple that you have seen a ladder, and a ladder has a weight, and its weight is acting downward. So due to which the ladder produces an anti-clockwise torque, and the wall exerts a force on the top of the ladder, and the wall produces a torque of a clockwise torque. So when you add these torques, both torques, anti-clockwise and clockwise, you know that clockwise torque has a positive impact and anti-clockwise torque has a negative impact. So when you add these torques, the answer would be 0. It means the ladder satisfies the second condition of equilibrium. So this is example of second condition of equilibrium. Students, now we're going to discuss the states of equilibrium. What are the 3 states of equilibrium? There are 3 states of equilibrium: stable equilibrium, unstable equilibrium, and neutral equilibrium. We'll discuss one by one these 3 states, and we'll explore these one by one. And the body may be in one of these states, one of these 3 states. So what is stable equilibrium? In stable equilibrium, the body comes back to its previous position when it is slightly displaced. So you have seen this is a book, and here is center of gravity. When the book is tilted, its center of gravity is raised. When the book is in stable condition, its center of gravity is in lower position. But when the book is tilted, its center of gravity is raised. So if the book is tilted, the center of gravity is at its highest position. But when the book is in stable position, its center of gravity is at its lowest position. So stable equilibrium states that when you displace a book, when you slightly tilt a book and the book come back to its previous position, that type of state is known as stable equilibrium. So a body which is in stable equilibrium is disturbed, its center of gravity is raised. You know that when disturbed, the center of gravity is raised. So this is stable equilibrium. When you disturb the body and the body comes back to its previous position, this type of equilibrium is known as stable equilibrium. Now, what is unstable equilibrium? In unstable equilibrium, a body, when disturbed, does not able to come back to its previous position. So a body is said to be in unstable equilibrium if it does not come back to its previous position when slightly displaced. And you have seen that in unstable equilibrium, when the body is in stable state, its center of gravity is at its highest position. But when the pencil topples over, its center of gravity is at its lowest position. So when a body is in unstable equilibrium, its center of gravity is disturbed, and in that state, when the pencil topples over, the center of gravity is at its lowest position. So this is unstable. In unstable equilibrium, the body does not come back to its previous position. Now, this is the example of unstable equilibrium. You have seen that the line, this is the line passing through the center of gravity, and when the pencil topple over, then its center of gravity is at its lowest position. Pencil just balance at its tip with the center of gravity at the highest position, and when topples over, the center of gravity as its lowest position. The third case is known as neutral equilibrium, and in this case, when a body is disturbed from its previous position, the body attains a new position. So this type of equilibrium, when you disturb the body and it attains a new position, this type of equilibrium is known as neutral equilibrium. Here, in this case, you have seen this is the center of gravity of the ball, and the center of gravity of the ball here does not change. It's a rolling ball, and this is the example of neutral equilibrium. So when you are discussing stable equilibrium, when you're discussing unstable equilibrium, and when you are discussing the neutral equilibrium, first you will have to define that what is stable equilibrium. The second, you will have to explain the example, and the third, you will discuss the center of gravity. That what does it happen to its center of gravity? So you will have to discuss these three cases. Now, students, we are looking at more detail in stable and unstable equilibrium, and you can discuss this example when you are explaining stable and unstable equilibrium. And how can you explain this example? Look at these three wooden blocks. So here, this is A position, this is B position, and this is C position. Here, you have seen that this is the center of gravity, this is the center of gravity, and this is the line passing through the center of gravity. So when the log is in stable position, it does not disturb, so this log is in stable equilibrium. When the log is disturbed, and you have seen that the line is passing through its center. When disturbed, the line is passing through its, the line which is joining the center of gravity, along the center of gravity, this line passes through its base. So the block will come to its previous position. So this is again in stable equilibrium. But here, you have seen, this is the center of gravity, the line passing through center of gravity, and you have seen that this line gets out of its base. Line gets out of its base. So when the line gets out of its base, then the block will never come to its previous position, and this is the case of unstable equilibrium. So you can give this example. This is a beautiful example when you are coding stable and unstable equilibrium. Now, there's a question arises that why is the vehicle made heavy at its bottom? What's the reason that the vehicle is heavy at its bottom? The vehicle is made heavy at its bottom to keep the center of gravity as low as possible. You have seen a car cultus. Its center of gravity is lower, and the weight of the cultus is heavy at its bottom, due to which the stability test of cultus is very good. You have seen a double-decker bus, and here you have seen that the center of gravity is not lowered, and at high speed there is a chance of toppling over that double-decker bus. So why the vehicle is made heavy at its bottom? To lower the center of gravity. So you are lowering the center of gravity, and when you are widening the base, you are widening the base. This is the base. You are widening from bonnet to the back. You are widening the base. when you're widening the base, you will increase stability in the car. So base is made wide so that vertical line passing through its center of gravity should not get out of its base during a turn. So that is why vehicles are made heavy at its bottom. So these are the three states of equilibrium, and these are so important. And this example of unstable equilibrium of a ball is also given in your book. So the ball will attain a new position. You have seen from the face that the ball will attain a new position. And in mutual equilibrium, we have discussed that the center of gravity will not change. Now, students, we are going to explore a problem of 4.9, which is in your book of page 105, where you have a numerical related to that condition. You have numerical. Here, a nut has been tightened by a force of 200 Newton using a 10 centimeter long spanner. It means the force is given and the moment arm is given. This is related to the principle of moments, where the anti-clockwise movement is equal to the clockwise movement. This is same. We have discussed the example of seesaw in second condition of equilibrium. So this is same. It is so interesting and is so important that it have a chance of coming in your exams. So a nut has been tightened by a force of, that force is the F1 force was applied to tighten the nut by a 10 centimeter long spanner. It means that a force has a moment arm of 10 centimeter, L1 10 centimeter. So when you divide 10 by 100, you have answer in meters. You know that when you are going from centimeters to meters, you will have to divide by 100. So the force is 200 Newton F1 and the length of the spanner is 10 centimeter, and in meters it will 0.1 meter. What length of the spanner is required to loosen the same nut? So find the length of the spanner used to loosen the nut. That will be your moment arm 2, L2, and the force to loosen the same nut with a force of 150 Newton. So that 150 Newton is force 2. Now it's so simple. Just you will have to write the formula of principle of moments, that clockwise movement is equal to anti-clockwise movement. And you know that when you are finding the torque or moments, you just are multiplying force with the moment arm. So multiplying L1 with the force F1 is equal to L2 multiplied by F2. Why is so? Because clockwise moments is equal to the anti-clockwise moments. So you can easily find L2, moment arm 2, L2, when you divide. This F2 is multiplying with L2. You divide it, so L1 multiplied by F1. So L2 is so simple, divide by F2. L1 multiplied by F1, divide by F2. So L2, the moment arm 1 is 0.1 meter, and the spanner used to tighten the nut is 1.1 meter. Force 1 is 200 Newton and force 2 is 150 Newton. So when you divide this, take the calculator, and when you divide this 0.1 multiplied by 200 and divide by 150, the answer would be 0.133 meters. And you know that you are going from meter to centimeter. You're going from bigger unit to smaller unit. Then you will have to multiply by 100. So 0.133, when you multiply with 100, the answer would 13.33 centimeters. I hope, students, you enjoy the lecture and you understand the basic key concepts that are very much crucial for your final exams. And I hope that you are preparing for your exams, you are not wasting your time, and you are settling in your homes. So my advice is to not to waste your time and work hard. and use that time. So stay blessed and stay tuned. Have a blessed and happy Ramadan. Thank you.